Hello everyone. Now let's discuss about estimation of total hardness of water by EDTA method. Means to find how much the hardness of the water by using this method EDTA. Now EDTA stands for ethylene diamine tetraacetic acid. Ethylene 2 CH2s are present. Next diamine 2 amines are present. Amino groups. Tetraacetic acid acetic acid, 4 acetic acids are present. This is EDTA. Now, assume that this is hard water. In hard water, if you add EDTA, then it forms a stable metal complex. This stable metal complex is formed. This is known as complexometric method. So, take a hard water, in that you add EDTA, then you will get stable metal complex. Then this method is known as complexometric method. Principle. First, take a hard water, means pipette out 20 ml of hard water. This is hard water. In this you add EBT. EBT is heterochrome black tea, which is a blue indicator, in the presence of ammonical buffer. So add hard water, EBT, ammonical buffer, and ammonical buffer composition is NH4Cl plus NH4OH at pH range 8 to 10. Then shake it, you will get wine red complex, which is unstable with calcium and magnesium ions. So take a hard water, add EBT in it, ammonical buffer, which is NH4Cl plus NH4OH, shake well, then you will get unstable wine red complex with Ca plus or Mg plus ions. So this is hard water. In hard water, if you add EBT, heterochrome black tea, which is a blue indicator, and you will also add ammonical buffer, which is NH4Cl plus NH4OH, NH4Cl plus NH4OH at pH range 8 to 10. Then you will get EBT, calcium and magnesium with EBT, unstable wine red complex, plus EDTA. Means when you add EDTA in this, then you will get calcium or magnesium with EDTA here. So this is wine red complex. In this wine red complex, this is that wine red complex. In this, if you titrate with EDTA, when you add EDTA, shake well, then this color changes from wine red to blue, clear blue, which is a stable metal complex. So when you add EDTA, this calcium or magnesium ions form complex with EDTA. So this EBT indicator, this EBT is replaced with EDTA and EBT is freed out. So all calcium and magnesium ions are complex by EDTA. The EBT is said to be free. EBT is free outside. Hence the endpoint is blue in color. Actually this is colorless. And the endpoint will get blue in color, which is a free. It is separated. But in the solution, this colorless plus blue, then the solution will be blue in color. It means the EBT comes out. And EDTA is complex with calcium and magnesium. This is stable metal complex. This is the principle. Procedure. First step is standardization of EDTA solution. Means we need to find molarity of EDTA. First, take a burette. Fill this burette with EDTA solution until the mark 0. Till 0 mark, you have to fill with EDTA solution. After that, take a conical flask. In that, pipette out 20 ml of standard hard water. Then, you add 2 to 3 ml of ammonical buffer solution, 2 to 3 drops of EBT in it. So, add 20 ml of standard hard water by using pipette method, and then add 2 to 3 ml of ammonical buffer, 2 to 3 drops of EBT. Shake well. You will get wine red color, this one. And here in burette, you add EDTA solution up to 0 mark, and then when it turns to wine red color, titrate EDTA. So this is the conical flask. Place it at the bottom of this burette. Titrate this with EDTA. So EDTA is added into this solution. Then at a point of time, this wine red color is changed to blue in color. This one. This blue in color. So then stop the titration. Note down the reading of this burette. Note down the burette reading, means how much EDTA you have used. It is the volume of EDTA. So M1V1 equal to M2V2. M1 is the molarity of standard hard water, which is 0.01, which is known. V1 is the volume of standard hard water, which is 20 ml, because you are taking 20 ml of standard hard water. V2 is the volume of the burette reading of EDTA. So how much EDTA you have used? It is the marked point. After taking, take the burette reading, then this will be V2, which is volume of the EDTA, how much EDTA you have used. Next, M2. M2 is a molarity of EDTA solution. This we need to find out. M2 equal to M1V1 by V2. So molarity of EDTA solution we can find by using this first step method. The standardization of EDTA. Next, step 2. Estimation of total hardness. Step 3 is estimation of permanent hardness. So first we need to find estimation of total hardness. Same. Fill the burette with EDTA. Take a burette, fill it with EDTA until 0 mark, and then take a conical flask. We put out 20 ml of sample water. Sample water means your tap water in it. We put out 20 ml of sample water. In this you need to add 2 to 3 ml of ammonical buffer and add 2 to 3 drops of EBT. Shake well. In conical flask, add 20 ml of sample water, 2 to 3 ml of ammonical buffer and 2 to 3 drops of EBT. Shake well. When you shake it, its color changes to wine red color, which is unstable. And then place it at bottom of the burette. Titrate with EDTA, means add EDTA into the solution until this wine red color changes to blue. So when the solution changes to blue in color, stop the titration. Note down the reading of the burette, which is volume of the EDTA which you have used. So V2 is the volume of EDTA by burette reading. You can find out by burette reading. M2 is the molarity of EDTA solution, which already we have calculated in first step method, molarity of EDTA. So we know M2, V2. M3 is the molarity of sample water that we need to find out. V3 is the volume of the sample water, which is 20 ml. We already knew this. So M3 is M2V2 by V3. So M3 is the molarity of sample water, tap water. So from this we can find total hardness as M3 molarity of sample water into 100 into 1000 ppm. 100 is molarity of CaCO3. So this is total hardness. Now let's find permanent hardness. So to find permanent hardness, same method, fill the burette with EDTA solution up to 0 mark. Then in a conical flask, take 20 ml of sample water. After taking 20 ml of sample water, you have to heat this heat this conical flask. Boil the water on a burner for 5 minutes. After boiling it, all temporary hardness is removed because this is total hardness. Now we need to find temporary hardness. Means now we need to find permanent hardness. Means we need to remove temporary hardness. To remove temporary hardness, we have to boil this water. After boiling for 5 minutes, and then you add 2 to 3 ml, let it cool down, and then transfer it into conical flask. Add 2 to 3 ml of ammonical buffer, 2 to 3 drops of EBT. Shake well. Same method here also. When you shake it, you will get wine red color complex, which is unstable complex, wine red color solution. And then place it at the bottom of the EDTA burette. Titrate this solution with EDTA. Do this titration until the color of the solution changes to blue color. When it changes to blue color, stop this titration. Mark the burette reading. So, M2 is a molarity of EDTA solution. Already in first step we got this answer. M2 molarity of EDTA. V2 is the volume of EDTA by burette reading. Again you'll find out, right? That V2 is the volume of the EDTA, means how much EDTA you have used. You can find this out by this burette reading. Next, M4 is the molarity of the boiled sample water that we need to find, and V4 is the volume of the boiled sample water, which is 20 ml, because you use 20 ml. So M4 is M2V2 by V4. So from this we can find molarity of the boiled sample water. Boiled sample water means water which is free from temporary hardness. So from this we can find permanent hardness, because there is no temporary hardness because we have boiled it out, boiled the water. So permanent hardness is M4, molarity of boiled sample water into 100 into 1000 ppm or mg per liter. This is permanent hardness. This is total hardness. Now we can find temporary hardness as total hardness minus permanent hardness. So total hardness minus permanent hardness is M3 minus M4, M3 minus M4 into 100 into 1000 ppm or mg per liter. This is temporary hardness. This is permanent hardness. This is total hardness. That's it. So from this we can find out hardness. We can estimate hardness by using EDTA method. Now there are three advantages of EDTA method. Greater accuracy, means you can get accurate reading, accurate hardness. It is more convenient method. You don't need advanced equipments. So it is greater accuracy, more convenient, and it is a rapid process. Thank you.